Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a walk in algebra through calculus, specifically looking at piecewise functions and graphs. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. So I'm excited to be joined by our two panelists, Vicki Carter and Tony Record. Vicki's been teaching high school math for a mere 42 years and currently serves as a math department chair at West Florence High School. She's a former co-chair of the AP Calculus Development Committee and served as an exam leader at the AP Calculus reading in the summer of 2018. She received the T-Cubed Leadership Award in 2015, and Vicki has served on TI-Nspire authoring teams, as well as presented at many national, state, and local conferences. Vicki, it's great to have you with us.
Thank you. A pleasure to be with everyone tonight.
And Tony has been a mathematics teacher at Avon High School, a western suburb of Indianapolis, for the past 30 years. For the past 12 years, Tony has primarily taught AP Calculus, and in addition to being a T-Cube regional instructor, Tony is an active consultant with both the National Math and Science Initiative as well as the College Board, having trained teachers and worked with students in 27 states. In his spare time, he loves to play guitar and is active with Central Indiana's Hendricks Civic Theater. Tony, it's great to have you with us tonight.
Thanks, Michael. Hello, everybody. It's an absolute pleasure to be with you this evening.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send questions to Vicki or Tony using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues, but in the event that you do, try selecting Communicate from the very top of the WebEx menu and choose Audio Broadcast. At this point, Tony is going to discuss our agenda.
Thank you, Michael. Certainly we've got our welcome and our introductions out of the way. We're going to probably start here in a little bit talking about our impacts, our mathematical practices. The focus initially here is on the advanced placement calculus standards, but we certainly know that all of you that are watching tonight aren't calculus teachers necessarily, but these impacts transcend Algebra 1 all the way up through calculus, and you'll probably recognize some of them from perhaps the NCTM standards. Obviously, a big focus of tonight is about piecewise defined functions, and we'll certainly see some that can be introduced at the Algebra 1 level all the way up through to pre-calculus. And we'll sort of follow this chronologically, and towards the end, we'll sort of provide a capstone and talk about both continuity and differentiability of piecewise defined functions and how they play a very dominant role in the study of advanced placement calculus. And then our final piece will focus on an actual former AP Calculus free response question, where we focus on the piecewise defined accumulation function. And then finally, Michael is going to take care of a wonderful drawing at the end that will allow one of our viewers a free admission registration to the 2020 T-Cubed International Conference, which will be held in Dallas, Texas, the weekend of March 13th through 15th.
Tony, thanks so much. And Vicki is going to discuss our expected outcomes tonight.
So first of all, we're going to talk a little bit about the impacts. As Tony said, we want to also bring to everyone's attention this idea of vertical alignment and some things that we can do in the earlier algebra classes, Algebra 1, Algebra 2, on up to pre-calculus, that will help students when they actually have to encounter piecewise functions being used in calculus, just be more familiar with them. So we're going to point out some ways that looking at the impacts might help a little bit there. And of course, our prime goal is to make sure that you can use the technology that we have, the TI-84 and the TI-Nspire, to graph and explore piecewise functions.
Vicki, thanks so much. Tony, you should have control. Feel free to share your screen.
All right. Thank you very much. And hopefully we're all taking a look now at these mathematical practices that we alluded to. Once again, these were sort of, I guess, they came down the pike through the recent 2019 Advanced Placement Calculus course and exam description change. But like I said, those of you who don't happen to teach AP Calculus probably recognize a lot of these as being carryovers from our old NCTM standards. And really, when you look at these standards, they permeate all through Algebra 1, Algebra 2, geometry, on up to AP Calculus. And by being conscious of these practices, you certainly provide a much more rich learning experience on the part of your students. Going into them a little bit more specifically here, we can break them down into some of their subcomponents, their sub sort of learning objectives, so to speak. And we have our first one in the implementing of the mathematical processes. One of the main pieces that we're going to be focusing on quite a bit this evening is to identify the key and relevant information to answer a question or to solve a problem. And if you move over there to the right for the connecting representations, I'd have to admit, Vicki and I would probably agree, this is an easy one to hit tonight when you're talking about piecewise defined functions, especially the two highlighted components, in that we are certainly going to identify mathematical information from graphical, numerical, analytical, and or verbal representations. Piecewise functions lend themselves very well to that. And then we'll be able to identify. Yes.
Yeah, and I just wanted to point out that it's so important to understand that not only are we going to look at graphing these piecewise functions, but also talk about what other information we can get from this. And we could do, we could work with derivatives, we can evaluate the function, even though it's defined in a piecewise format. We could even have a contextual application and a verbal representation. So it's so important to start this early in their high school careers talking about these piecewise functions. Thanks, Tony.
Yep, perfect, yep. And finishing out the connecting representations, we're certainly talking about identifying how mathematical characteristics or properties of functions are going to be related in the various representations that we're going to see. Justification, sometimes it's our students' favorite word, but we're going to be able to apply technology to develop claims and conjectures. That's certainly a wonderful aspect of TI graphing calculator technology. And of course, the communication and notation piece, which is certainly receiving a great deal of attention in the past few years. We will certainly use these appropriate graphing techniques in order to communicate our findings. So those are our impacts. And with that, I believe that I am going to switch over screen here and share something with you all. And we are now looking at, hopefully, a file entitled Dog Days or Dog Years. Now, this is a TI-Nspire activity. It is available at education.ti.com, as are countless other activities. And our purpose for showing you this is to take an activity that's been on the site for quite some time, just to show you utility that this particular activity has. If you're teaching Algebra 1, it's very likely that your students have never seen a piecewise function up until that point, and Algebra 1 is certainly an appropriate place to initially expose your students to piecewise functions, certainly after they've probably spent some time graphing some linear functions. And typically, an Algebra 1 student may not be a whole lot interested in a piecewise function. Exactly what is it? You know, the first question that they're probably going to ask is, when are we ever going to use this? And I think this activity lends itself very well to that. Like I said, this activity, it's been around a while. I believe it was written and developed in 2011, 8 years ago, which begs the question, is that 56 years in dog years? Well, that's something that we might be addressing here. So the makeup of this activity just starts with an interactive page here, where we've got our good friend, the dog Spot, and where we can input Spot's age and expect to see an output that would be the equivalence in human years. So if we play around with this by just double-clicking, hitting the click pad a couple of times to activate that interactive box, we could change that number and interactively see how the output changes. Now, you don't have to worry about writing these numbers down because we're going to show you a table here in a moment. But it seems like this dispels that common myth about there are 7 people years for every 1 dog year. So we can see how this is certainly changing. And by the time we get to a dog who's age 3, it seems like the output is slowed down a little bit. And we could go up to an older dog. In fact, I have a dog sitting right here at my feet who's 13 years old. I guess is now eligible to draw Social Security. And we could go kind of crazy to the Guinness Book of World Records, where I guess there was an Australian sheepdog who lived to be 29 years old and passed away back in 2016. So what does all this mean? Well, if we take a look at the next page, it says that we're going to be able to see a table of values for Spot's age and his age in human years. And then there's a scatter plot. So if you remember a few of those entries that I initially had put in, the output is displayed very nicely in this table. And then we also have the added benefit, that multiple representation of that particular scatter plot. Now I want to make mention that this activity actually is a lot more robust in the form that you're seeing tonight. I've actually streamlined it a little bit to kind of focus more on the piecewise function. But if this is an activity that you think your students would be interested in, I certainly would recommend checking out its entirety on the TI website. So we look at this and we start thinking a little bit, is this a linear function throughout? And it's probably very likely that your students will say no, that it isn't. So what we can do with this is start kind of thinking about, well, at what point does the rule change, essentially? And it appears to be at the age of 2, things start to change a little bit. And of course, we could graph a linear function that goes through the origin that has a slope of, well, the students could look at this and hopefully deduce the fact that the slope would be 10.5 for the first few terms. But then after it slows down a little bit, it looks like our slope is going to settle in with a value of 4. And that's what we're going to see with this piece. And I wouldn't worry so much about if the students initially graph 2 lines that don't have a domain restriction and, of course, would cause us to not have a function. But that would then open the door to talk about restricting those domains so that we have a piecewise function because, after all, it has the word function in it. And so the rest of the pages sort of would talk through that particular possibility about identifying what the slope would be of the first scatter plot and the second scatter plot, as I just mentioned. And of course, we can dispel the myth, true or false. Those of you who potentially might have the Navigator system, this would be a wonderful quick poll opportunity. And hopefully students would realize that this is indeed false. And I want to make sure I point out that the information in this particular activity was gleaned from a team of veterinarians and the research that they have done. So it's pretty factual data. And as an extension, if your kids just can't get enough of this dog age converter, there is a cat age converter as a part of this activity as well, where we have Fifi. And you can do a lot of the same kinds of manipulations. All right. I am going to turn over to my colleague, Vicki. And Vicki's going to talk a little bit about settling in with Algebra 1. And she's going to use the TI-Nspire CE to kind of talk about its capabilities and functionalities as far as piecewise functions are concerned. So, Vicki, I believe the screen is yours.
Okay. All right. So what you should be seeing is the view screen of the TI Smart View for the TI-84 CE. And what we are so happy to say is that there is now a built-in piecewise grapher. And so I'm going to sort of go through the instructions of how to use it, and then we're going to see several examples and talk about what students might do from Algebra 1, Algebra 2, maybe up to pre-calculus with this piecewise template that we're going to actually utilize. And then we'll go over to the TI-Nspire and sort of look at some of the same things. So first of all, I need to access the piecewise template. It is under your Math key, so I'm going to press Math. I'm going to scroll down this list because it's sort of near the bottom. For those of you that are very familiar with this calculator, you would know that you could have also pressed the up arrow and maybe gotten to this a little quicker. But there's our piecewise, and so we're going to press Enter. You get this little screen that comes up that says, well, how many pieces do you want? So let's start simple and just have 2 pieces. So the little arrows are blinking, so I'm going to press the left arrow to go down to 2 pieces. Then I have to press the down arrow to get to OK. And then when I press Enter, I'm actually going to have a piecewise template that looks like the way that a textbook prints a piecewise function right here in my y1 equals. So we're going to graph 2 linear pieces. So I thought maybe we would look at one piece that has a positive slope. So let's try 2x minus 1. And then I press the right arrow to get to the box that will define the domain for this piece. Let's make it really easy. Let's do x, and I want this to be less than or equal to 0. Now the way that I access my inequality signs is under it's test here, so it's blue, so I press second, math, and I need to go down to my less than or equal to. I could have also pressed the 6 key to get that, and so we're going to press 0, and then I'm going to press my down arrow and left to get to the other place to put the second piece. Let's do a negative slope this time. Let's do negative 1/2 of x, and let's do plus 3. And then again, the right arrow, and this time let's do x greater than 0. So we'll do x, and we'll do our second math to get our inequality. And so we have greater than 0. And let's see what this looks like. So we'll press graph, and we have our standard window. So for the calculus teachers out there, or even pre-calculus, you would realize that we have a jump discontinuity. But I think it's really good for students to see these 2 pieces even as early as an Algebra 1 class and start talking about the fact that there's a separation in the graph. Of course, you would not use the word discontinuity, most likely, but you could definitely say that the 2 pieces are not connected. So we could look at a different window. So we could zoom and maybe zoom decimal. So I'm going to show you how we can just press the 4, and it would show us this. Just a little clearer about the jump discontinuity. You can also talk about the y-intercept and the fact that we can see the left side piece and then the right side piece, and we can actually see those y-intercepts and sort of talk about that slope of positive 1 and negative 1/2. So one of the things that you could also do is press the trace, and so I'm going to go up here to trace. I'm just going to go left a little bit because what I want to do is sort of approach that jump that we have. So now I'm going to move to the right, and I'm going to notice my values at the bottom. So I'm actually seeing values on that linear piece. And notice that when I get to 0, remember we defined this left-hand piece for less than or equal to 0. So it tells us that at 0, our y-coordinate would be 1. But if we click one more time to the right, it jumps up to the other piece, the piece that is defined for x greater than 0. And so now we could trace along this piece and see values of the function. So I really would encourage algebra. I know it's probably not in most textbooks, but I would really encourage the Algebra 1 teachers to at least explore this a little bit with your students, maybe an extension lesson one day or something like that, so that they have exposure to seeing these kinds of functions. Now I want to try one more thing with you. So I'm going to go to my y equals. I'm going to clear that. So we're going to review how I got the piecewise template there. So we press math. I'm going to show you how if I press the up arrow I can actually get to the piecewise template a little bit quicker. Again, I want 2 pieces just to make it easy, and OK. So this time I'm going to type x plus alpha a. And then I'm going to define this piece for x less than or equal to 2. So I have my second math to get to the test. And I want less than or equal to 2. And I'm going to go down. And this piece I want to be negative x plus 1. So what I'm sort of doing is introducing a parameter for the students. So we want this to be, oops, I pressed the wrong button, sorry about that. So we want this to be greater than 2. Okay, we'll press graph, and we actually have 2 pieces, so it's kind of like, oh, well, what was A? It's probably the last thing that I stored as I played with this earlier today. So we're going to go to just our calculation screen, and we're going to store some values for A. So let's try 1. So I'm going to do 1 is stored to alpha A. I do have to press enter. I'll go to my graph, and I notice that I get a change in the graph. So what we might challenge the students to do is to get the 2 pieces to connect. Now, you would need to discuss that the fact that changing A is actually going to change the y-intercept of the left-hand piece. So what would our y-intercept need to be in order for these 2 pieces to meet? Well, I imagine a lot of students are going to play guess and check. So let's play their game a little bit. So let's try negative 1 is stored to alpha A, and enter. And let's see what the graph did. So we got a little closer, but we're not quite there yet. So just to save time, I'm going to tell you that what you really needed to try is negative 3. So there's a lot of discussion that you could have about why it would need to be negative 3. Some students will just be lucky and find it. Oops, sorry about that. You got to store it to A. Press enter. And so now we can see that the 2 pieces actually connect. And so it could be a nice little challenge for your students. So let's go back to the y equals. So as students move up to Algebra 2 and into pre-calculus, of course, we might want to challenge them with having pieces that are different kinds of functions. So let's actually change this to x squared. Let's put a parabola here. So x squared. We won't do the little parameter thing, so we'll put something like x squared plus 2. And now let's look at that graph. And you can see the piece of the parabola. We may want to change our window. So we could go to, we'll just go back to Zoom Standard. And we see our piece of our parabola and then our linear piece. But you could put together more than 2 pieces. You could use exponentials and quadratics. You could use some trig functions with some linears, perhaps in the pre-calculus class, but there's a lot of opportunities to introduce some piecewise functions in courses prior to calculus. All right, Tony, what do you think? Are you ready to show them some of the same kinds of things on the TI-Nspire?
Yes, that sounds great. Let's do that. Let's do that.
Okay. So I'm going to send it to you. All right, Mike, do we have any questions we need to address in the Q&A right now?
The only question I saw recently came from Tracy, and Tracy was asking, is there a way to graph these without that particular function? For some reason, it was working on the 83 plus, but didn't work on the 84. And I'm just trying to think why that would be the case, but I can't think of anything.
I can't think of anything either.
Okay. All right, thanks.
And I noticed that there were a few of you that are 84 CE users that inquired about the fact that the piecewise function feature wasn't available. But if you make sure that you check the chat dialog, Michael has addressed that, and it's a very easy download. It's completely free. You would just make sure that you have the TI Connect software, which is a free download from Texas Instruments for PC or Mac. Basically, it just allows your computer to be able to communicate with your handheld device. It's very likely that you have a mini USB to USB cable hanging around, and that's how you would connect the calculator to your computer. And it's very simple. The latest operating system for the 84 CE is 5.4. However, this particular feature for the piecewise function came out in just a slightly previous operating system. It's almost been about 2 years ago, I believe, if I'm not mistaken. It's one great thing about Texas Instrument calculators. They're always upgradable, and new features come on the horizon from time to time. I'm hoping everybody is seeing the TI-Nspire screen here, or graphing a piecewise defined function on the Nspire. A lot of similarities between what you saw Vicky show on the 84. The interface is just a little bit different. So if I move to my page 2 here with my sort of blank graphing template, in order to bring up my graph entry, one of the easiest things to do is to hit the Tab button. And to generate a piecewise function on the Nspire, we can go to our very handy math template. That's the button over here next to the 9. And if I press, a whole wide array of different mathematics goodies show up. And the thing that we want to be a little careful about is up here in the top row, there seems to be a series of few templates that look kind of similar. And it's very easy to confuse these. The piecewise function templates would be the two that my cursor is moving back and forth between. They're denoted by the commas that will kind of depict the domain restriction. These other two, which are often confused, I see my students sometimes gravitate towards those, but those are used to solve, set up the solutions to systems of equations. So we'll do a simple piecewise function, so I'll choose this option. And you just pretty much fill the entry with what you're wanting to sketch. So let's say I go with a linear piecewise at the top, 2x minus 1. And we'll say that that is valid for x less than 3. And then for my second piece, we'll go with negative x plus 7. And we'll say that that's valid for x greater than or equal to. Once again, to access your inequality symbols, Control equal button will bring up all of those options. And we want the greater than in this case, greater than or equal, I should say, in this case, with our 3. We hit enter, and we see our wonderful piecewise function develop. If you wanted to dress this up just a little bit more, for those of you that use the TI-Nspire, and if you're working within a document, and that's very important because you can't do what I'm about to do if you're just using a scratch pad. But in a document, you have this wonderful feature with the menu button called geometry. And although it doesn't seem like we're going to really do geometry in its sort of innate definition form with this particular problem, I am going to add a point on this particular graph. So I'm going to select option 1 and then follow that with option 2, a point on. And then that will allow me to select which piece of this piecewise function I want to place that point on. And I'm going to choose the right side first and just kind of slide that point up to the very end. Click so it takes hold. And while I'm still in that point on mode, I will do the same thing for the other piece. Okay. Now, those ordered pairs, I don't really want to have them hanging around, so I'm going to get rid of those. So I'm going to hit escape. That will allow me to leave this particular point on tool. And I can then hover over any of these points, and I could just basically hit Control Menu. Control Menu will allow me to use any of these particular options. I'm right now interested in just deleting them so that they go completely away. So Control Menu, and then delete. Now you might ask, well, why did I do that? Well, if you wanted to really kind of work on this from a cosmetic standpoint, you could actually go into each of these and dress them up a little bit more. So by hovering over, say, the right side point, I can hit Control Menu again. Control Menu is sort of like a right mouse click. It allows you to bring up some more different contextual menu items than, say, just a pressing of menu will. And I want to choose the attributes. What I want to do with this is I want to turn this into something that maybe I want it to be a little larger. So I can just cycle through that first option and come across various options. And let's say I go to large, and I'm very happy with that. And I'm also happy the fact that this is a circle that's been shaded in, as is indicated by this particular part of the piecewise function. Now, I may not be very happy about its color, but if you wanted to change its color, that's just a matter, again, of hovering over, Control Menu, and it's probably pretty clear that you're going to go with the option B, color, in this case. And then, even though this is a dot and not a line, that's the only option that we really have to use, line color. And if I want this to match the rest of my graph, I'll just call it, say, blue. Now, obviously, this is not really good because we don't want the same thing to be happening with this other point. So I'm going to go in and hit Control Menu and change the attributes, option 3. And this time, I'd like this guy to be an open circle. And maybe I want it to be a large open circle. So you can see there are 13 different options. And if I just hit the right button, it'll cycle through. And option 9 is a large empty circle, at which point I'm satisfied. But if that little bit of OCD is in you that you're thinking, oh, I got to have this to be the same color, it's just a few clicks of the button really to change this to the color that you want. Now, I guess one of the reasons why I'm showing this to you is that, those of you that may use the TI-Nspire and have the software, I find that this is a wonderful tool to use to generate wonderful graphs that I can then embed into my Word files or PowerPoint presentations. There's many ways that you can do that, and that's something that we could certainly discuss at some other time. But one of the ways that I like to do it is just using the snipping tool. Using the snipping tool from Microsoft that does a pretty good job with this. And before I get too much farther with this, I want to make mention of the fact that perhaps you are teaching at a classroom where you have a wonderful set of TI-84 calculators, or maybe even 83 calculators, which are certainly servicing your students well. And there's really no reason that you need to change that. Be advised that I do know a lot of teachers that still use the TI-Nspire software to present things to their students, even though the students have the TI-84 models in their hands. It's something that I see actually a lot more commonly in the last few years than say, prior years before that. And the impact that it has, the teacher said, is pretty profound. And the students, they don't get confused, but it's a great way that you can sort of have the best of both worlds in your classroom. I'm going to take another look at another piecewise function here just really quickly. I'm going to pull up a template. This time, if I want to graph a piece that's got 3 pieces or more, I'll choose this option here, and a dialog box is going to pop up, and it's going to ask you, well, exactly how many pieces that you want, very similar to what we saw earlier with the TI-84. Let's say that I'm satisfied with 3, but I could go up. I could also go back down, and lo and behold, if that worked, and let's pull up the tab entry. Let's try that again. I don't think I hit enter very well. Let's try this again. Pull this up. Say, yes, okay, I definitely want 3. Well, okay, third time's a charm. Time's a charm. I think I never did officially tell the calculator I wanted 3. Even though the 3 was highlighted, it wasn't sort of entered the way it should be. All right, so let's go with x plus 6. And I'll define that when x is less than -1. And then let's do something a little crazy here. Let's take a look at a parameter like a. Let's put in some kind of a value that we don't really have knowledge of at this point. And then I'll multiply that by x squared. Now, it's very, very important that if you want to use a parameter like a in this case, you must use this multiplication. That's really important, because if we don't put the multiplier in between, the calculator is going to treat this new variable that you entered as AX. X is a single variable value. So that multiplication is very important. And let's say that we define this to go from -1. Whoops, let's go -1. And I better use, let's get back here. Let's use a less than or equal to X. And let's go ahead and let the left inequality, or the right side inequality here, be a less than or equal to as well, 2. And then for the last piece, I'll put, let's say, another linear piece with a negative slope, -2x plus 10. And he's defined when x is greater than 2. So what's going to happen if I hit enter? Well, if I hit enter, what happens is I did not delete this slider A, is what happened, and it is using a value that I have stored into the calculator, which is completely my fault. However, I'm going to show you another document here in just a moment that's going to allow you to kind of manipulate that particular slider. All right, it's going to make a lot more sense, I think, if I go straight to that activity than kind of delete this one. But I probably saw that coming because this A was bold and it's kind of being recognized by the calculator. But and essentially what you could do with a slider is you could change it in a very similar way that Vicki showed to change things up a little bit. Let's see that in action. Yes, go ahead.
Okay, if you've got another document that will show it, I was going to say you could just change it to another letter and it would.
Yeah, I could do that, I suppose. Yeah, if A is not good enough for us, let's try B. Or N or whatever. Let's try B. Do you see the difference? When that B is bolded, or if that A was bolded, I'm kind of in trouble because it's in my practice session I had used A before. But yeah, let's say we use B. This is the dialogue that we talked about. You're going to see this particular window pop up, and we say, yes, we do want a slider for B. And at this point, we can kind of move this B value around a little bit. There's a lot of different ways that we can kind of present this particular slider. One of the things that I like to do is to minimize it a little bit. And instead of using a sliding bar, we can change it to feature arrows that can go up or down. So by hitting Control Menu, we can then open up some settings for this particular slider. We'll choose option 2, minimize for right now. So now I can just kind of click on this back and forth, and you can see how the value of B changes. And accordingly, that middle piece of the function is going to change as well. And for those of you who might teach a little bit of pre-calculus or calculus and you talk about continuity, you can sort of see that there's no single value of B that's going to make the whole entire graph continuous, right? We're kind of okay with a value of B to produce continuity on the left side, but on the right side at the same time, that's going to be kind of tough. In my next particular document that I created, this is where we really step into the idea of calculus. And even those of you who don't teach calculus, you probably have all taken calculus, so this could bring back some good memories. But at least you get to see where your students are going to be going in a year or two with the knowledge that they might gain in your class with the discussion of piecewise functions. So in my first problem, what I have here is this arbitrary piecewise function where I have this parameter A. Now, I know that I don't have the multiplication symbol in here, and the reason for that is that this is just a notes page. This is not something that's going to be actively referenced in terms of the computing power of the calculator. Our job is to find the value of A that would make this function continuous. So students can actually solve this by pencil and paper. Now, if you look at this, again, this is just a notes page. I know it's kind of busy, but it's probably likely that the students might be working this out with pencil and with paper to figure out what that value of A is going to be. I do know a lot of teachers that use the TI-Nspire in a very sort of paper-free way, and you can actually put notes like this on the Nspire. They can be sent out to students via the navigator, and they can call these notes up and study them. So what we've got here is a situation where we need to focus on the one-sided limit, right? So we take a look at the limit of f of x as x approaches -1 from both the left and the right, we can see that we can directly substitute the -1 in. And by doing that, we would end up with -a plus 5 for the left side limit, and then we would get positive a for the right side limit, as that -1 squared becomes +1. And when we solve this equation, we sort of see the progression that leads us to a being -5/2. Well, what I have on the next page is that very function already entered into the calculator with the slider, with the correct value a at this time. And we see that with a slider value of 1.5, we don't have that continuity we'd hoped for. So the students can manipulate the slider just a little bit, and they can find, okay, well, what is that value of a that's going to make this a continuous function? And by the time they get to this 2.5, they realize that that corroborates their findings from before. Now, the slider settings, if I show you just that one more time by right-clicking or Control menu and hitting Option 2 Settings, you have a lot of freedom here with your sliders. You can choose what the smallest value would be, what the largest value. You can even choose the step size. Now, you'll notice my particular slider here was set in such a way that I had the initial value set at a fractional value with a step size of 1. But that could easily be changed, and let's say I start the value at 1. I could then make the step value 0.5, and I'm still going to have the same functionality. Once I hit OK, we should be able to see this slider moving in 1/2 increments. Now, initially, a student may not know that if they didn't do the pencil paperwork to know that the answer is -5/2. A lot of times a student will assume that the a would be an integer value. And on this next page here, it's essentially the exact same problem with sort of a split screen approach, where on the right side I just have a notes page where I've actively put in some math boxes with that particular one-sided limit. And so what we get to see here now is just a little bit more dynamic approach. We get to see how those limits are sort of changing at the same time the graph is changing as well. Again, multiple representations. And it's kind of nice in this case that that open circle on the right side of the piecewise function on the parabolic side does get covered up very nicely by that closed circle when a is 2.5.
So, Tony, this is just a great dynamic way of trying to get students, as you just said, to visualize the mathematics that they did by paper pencil. And I think that's just one of the highlights of the TI-Nspire is that we have this power of visualization. So even if you don't have, as Tony said earlier, the TI-Nspires in your classroom, and say you had 84s, it's fairly easy to get the software so that you could do some demonstrations with the TI-Nspire software for your students, because I think them seeing this makes it so much easier to understand what's actually happening.
Yeah, very true, very true. And if you just want to try out the software, you can get a 90-day free trial to play around with to see if it's something that you think you'd continue to use. So good point. And then real briefly, I have a very similar problem. Those of you that teach AP Calculus are probably familiar with the next stage of these kinds of problems where you might have two different constants, an a and a b. And with this particular problem, you're supposed to find the values of both of those that will make this function differentiable. Okay, well, if we look at the pencil paper approach, what we see going on here is if we focus on the idea of differentiability, one of the early things that we're going to want to do is to indeed take the derivative of the piecewise function. So this is something that you would certainly teach after your students learn at least the power rule shortcut for taking the derivative. So you can see from the a times x cubed, the derivative down here, my f prime turns out to be 3 times a times x to the second power. But since my x is going to approach 2 and I have a very nice continuous piece, I'm allowed to directly substitute the 2 in. Likewise, we'll do something very similar for the green, the bottom function, whose derivative is 2 times x, but as x approaches 2 from the right, I would get 2 squared. So when you set these two pieces equal to each other, 12a is indeed equal to 4, which leads us to an answer of a equal 1/3. Now, some of my students will say the answer is a equal 3. but hopefully most of our students will say A is 1/3. So, the question here is, well, where do we go next? We found the value of A. We're very proud about that, but this B sort of disappeared. And so this is a wonderful opportunity for our students to kind of connect the idea that if a function is indeed differentiable, we also know that it is continuous. And that's pretty much what we see on page 2.3, the same exact approach that you saw in the previous problem, but now instead of dealing with a limit of f prime of x, I'm just going to go back to my good friend f of x here and find the two one-sided limits. And it ends up producing a result of 8a for the left side and 4 plus b for the right side. And fortunately for the kids, for our students, that they didn't have to solve a system of equations with this problem, in that they already found the value of a to be 1/3, so they can just directly substitute that. So I guess this was a system of equations light, so to speak. And if we do the arithmetic and solve for b, we would get -4/3. And what I've done is I've made another page where now I have both sliders active, moving around. And it's a little tougher because you've got to kind of manipulate two things at the same time to kind of see if we're going to have that continuity. And you just play around with them a little bit. Seems like I got pretty close there. Maybe it's the b value that needs to be changed. Maybe that's what I want. Maybe that's not what I want. That's a good point. Well, again, you might have to go ahead and change the slider settings, especially if the student knows the answers are going to have denominators of 3, then it's very likely that we probably want to use a slider setting of 1/3. My last page here, I've got the same idea, a little bit more dynamic with the fact that I've got, scroll this down so we can see both parts, but I've got the derivative limit as x approaches 2 from the left and right. And then I have up above the original function to sort of test for continuity. And you know what? I think this is probably something that ought to be changed because that doesn't make a whole lot of sense. Let's make that a plus. Okay. And then if this is in a math box, I better hit enter so that we're activated. There we go. So then if I test my sliders and make sure that I've got the right settings one last time, I like the fact that the step size is going to be 1/3. Let's go ahead and make this value something real basic, something like 1, so it's going to be pretty well behaved. And then I'm going to do the same thing for slider B. Again, you just hit the control menu button to bring up this contextual menu, choose settings, and I'd have to say I'm pretty happy with the way that this slider is behaving. So now I can go ahead and start manipulating them, and if with any luck, we'll have the right answer. I'm trying to remember what the values for A and B are. Does anybody remember? Does anybody remember? I think A was 1/3, if I'm not mistaken, and was B -4/3. Is that right? Does that sound right? -4/3. That would be -1 and 1/3. It looks good. If you take a look at the right side, you've got the same values here, and you've got the same two values here. Unfortunately, I'm tweaking this a little bit because I didn't quite get my open circle to be underneath my closed circle quite as nice. So, but that's a kind of an activity that you can use as a introduction. You could use this as sort of an investigative way to kind of connect continuity and differentiability in an AP calculus class. I'm going to bring up our final little document here that Vicki is going to take over the commentary on, and I'll do some of the driving here. But this is going to take us back to a fairly recent AP Calc exam question. So Vicki, take it away.
Okay. So in this particular question, and this is from the 2016 exam. It's an operational question, so it's freely available to the public. And I do want to mention while Tony is on this page that if you are curious about having a very thorough discussion or listening to some videos that are very thorough discussions of both the use of the calculator and just general calculus for the 2017, 18, and 19 free response questions on the operational exam, you can visit that website that he has there, and it's called TI in Focus, and it's just great resources for calculus teachers. But this particular question was before we started doing these videos, and so I wanted to present it. It's a piecewise linear, and it's kind of a little bit overwhelming at first. So Tony has a clip of the actual question here. So it says, in the stem of our question, the figure above, which is actually to the right now, shows the graph of the piecewise linear function f, and on the closed interval from -4 to 12, the function g is defined by g of x is equal to the definite integral from 2 to x of f of t dt. So most of the calculus teachers will recognize that as something that we would call an accumulation function. So that integral is accumulating areas from 2 to whatever our x value is. Notice that it's really cool. It almost looks like the Alps there with our pieces. So what I actually did was graphed it. I did kind of cheat a little bit and used absolute values to reduce the number of pieces that I needed to graph. The questions on the actual exam were things like, does G, and the students do have to keep their G and their F kind of in their mind as to which they're talking about. Does G have a relative min, a relative max, or neither at x equals 10? And they had to justify their answer, and then there was a point of inflection question. Then there was an absolute minimum, absolute maximum value question, and then an interval on which g of x was less than or equal to 0. So, Tony, if you will go to the next page that actually shows this graph as produced by the calculator, and if you would just press tab and go up to the F1 definition. So that's kind of how I put it together, is the three pieces. And then I did one of the things that Tony showed you earlier today and put the points on the graph, and I actually found the coordinates so that this graph that you're viewing looks just like what was on the AP exam, essentially. All right, so let's press escape right there for just a second. So let's take a different question. Let's ask the students, where is the graph of the g function increasing? So what we have to realize is that we need to take the derivative of g, but the derivative of g is going to be the f function, the graph of the function f. And so if we want to know when g is increasing, then we need to know when its derivative is positive. So if we're actually looking at the graph of f, then we need to know when f is positive. So we look at this and we see that it's the interval from -2 to 6. There have been lots of discussions lately about, well, what's going on at x equals 2? That actually needs to be included in your interval over which the function is increasing. So technically it would be a closed interval from -2 to 6. So I decided what would be really cool is, even though this was a non-calculator question, let's really use technology to its fullest extent, and let's see how the TI-Nspire graphs this antiderivative. It's really nice because it's really clear now that we have that increasing interval from -2 to 6. And now Tony's going to do something real quick, and we're just going to do this fast. He's going to go down to that lower limit in that definite integral, and instead of the 2, the way the function was defined on the AP exam, we're going to change this to that parameter a. So we're going to put in an a, and if you recall, are we going to have a problem with a? Yep, we're going to try C.
I'll go with C. How will I go with C? Okay, it's C's turn after all. Okay.
It is C's turn. And so this should produce a slider. And it does. And so we're going to say, okay. I would not do this probably on a handheld because it's going to be, I imagine it's going to be a little bit slow. So Tony's going to minimize it. Now, the neat question to ask the students is, will changing that C value change our interval over which the function is increasing? How will it change that graph? And if you notice, it's actually a vertical shift. And I just think that is so interesting that we can actually see this taking place. And if you notice, your graph is the same. It's just shifted up and down. And so, Tony's going to get the little slider a little bit out the way. And so our interval over which the function increases, the g function increases, is going to remain -2 to 6, regardless of what that C value is. And this is that unbelievable power of visualization that we get with the TI-Nspire. And again, I really hope that you can take an opportunity to show this to the students. So someone just asked if this document was available to download, and I think it is going to be part of the downloads that you'll receive at the end, or like the link that you will get at the end of the webinar that I put together. And I think, Tony, yours will be too. Am I right?
Definitely,
okay.
Yes.
And we are at 8:55. Tony, anything else before we turn it back over to Mike so that he can give us all of our closing information?
No, I'm just geeked out right now. I'm just, gosh, anytime you can talk with 100 or so of your best friends about mathematics and Texas Instrument Graphing Calculator, that's a good evening. Or for my Australian friends, that's a good morning for you guys. So that's great. That's great. I'm going to turn this over to Michael.
Thanks so much, Tony. With the last minutes we have remaining here, if you have any questions for Vicki or Tony, please try to get those asked. I know they'll do their best to get those questions answered. We're in the tail end of TI's Extra Credit for Teachers contest. Whenever you participate, you gain entries into drawings, and that will let you gain possibilities of winning different things like TI technology, T-shirts, things like that. And so doing things like you're already doing, like attending a webinar tonight, you can visit our website to enter a code which gains you those entries. Tonight's code, it's not case sensitive, it is Piecewise. I'm going to type that in the chat window here in a minute. Again, that's Piecewise. It's tonight's code for the Extra Credit contest. And as Tony mentioned almost an hour ago now, we're excited that the T-Cubed International Conference is coming to Dallas this coming March. Tony's geeked out to be spending just an hour with you guys, but imagine spending a couple days with like-minded people. It really is a great conference to be at for lots of reasons. You can really learn more about content, pedagogy, technology, and any combination of those. So please feel free to visit our website to learn more about the T-Cubed International Conference and consider joining us there. Also tonight, to one lucky winner, we're giving away a free conference registration, and tonight's lucky winner is Susanna Gould. So Susanna, congratulations. We'll be in touch over email to give you a little more information in the next couple of days, but we hope to see Susanna as well as everyone else at the T-Cubed International Conference. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, and we really hope you'll share your thoughts in the post-webinar survey. To receive a certificate of attendance, go and click that link in the chat window. As promised, there's also a link for the documents tonight from Vicki and Tony. They did a great job putting those together. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. And if for some reason that you're having any problems with either of those two certificate or documents links, just hang tight in your email. A couple days, you'll automatically get a follow-up email, which will contain links for the certificate, the documents, and the recording. That way you can follow along at your own pace and then pause and rewind as necessary. Lastly, if you're in need of any post-webinar follow-up, feel free to give us a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. We love hearing from you. Thanks so much, Vicki and Tony, for everything you guys shared tonight. It was great.
Loved being with everybody. I just get really excited sharing great things that the TI calculators can do with the audience that we have.
Oh, yeah. Thank you so much for taking time to watch us, whether it's live or on demand. And just keep up the great work that you're all doing, because the work that we do, it truly does matter. So just keep it up.
I agree. Thanks so much for joining us, and we hope to see you back online next week. Have a great night.
Good night, everybody.